All right, so today we're talking about system of inequalities. We're going to solve system of linear inequalities by graphing, and we're going to apply system of linear inequalities. So Jakui is beginning an exercise program that involves an intense cardiovascular workout. Her trainer recommends that for a person her age, her heart rate should stay within the following range as she exercises. It should be higher than 102 beats per minute, and it should not exceed 174 beats per minute. The graph shows the maximum and minimum target heart rate for people ages 0 to 30 as they exercise. If the preferred range is in the light green, how old do you think she is? Well, it should be no higher than 102 beats. So we can go here. 102 would be approximately right in here. And then it should not exceed 174. 174 would be about right here. So her age is probably about 15 years old. Okay? All right. So the graph that we just looked at is a graph of two inequalities. A set of two or more inequalities with the same variables is called a system of inequalities. The solution of a system of inequalities with two variables is the set of ordered pairs that satisfy all the inequalities in the system. The solution set is represented by the overlap or intersection of the graphs of the inequalities. So let's take a look at that. It says solve the system of inequalities by graphing. So we have y is greater than negative 2x plus 1, and we have y is less than or equal to x plus 3. So the y is greater than negative 2x plus 1 is this line. Remember that it is dotted because it does not include the points on the line. It just includes all the points on this side. Okay? And then y is less than or equal to x plus 3, which is this line, and it's a solid line because it's or equal to, and it would be all of the area below. Well, you will see that they overlap in the light green area. Okay? So the graph of y equals negative 2x plus 1 is dashed and is not included in the graph of the solution. The graph of y equals x plus 3 is a solid and is included in the graph of the solution. Let's see. The solution of the system is the set of ordered pairs in the intersection of the graphs y is greater than negative 2x plus 1 and y is less than or equal to x plus 3. This region, as I said, is shaded in green. When graphing more than one region, it is helpful to use two different colored pencils or two different patterns for each region. This will make it easier to see where the regions intersect and find possible solutions. So all our solutions would be in that light green area. All right. So sometimes the regions never intersect. When this happens, there is no solution because there are no points in common. So for example, solve the system of inequalities by graphing. We have 3x minus y is greater than or equal to 2. So, excuse me. And then we have 3x minus y is less than negative 5. So you see when these are graphed, you have this area and you have this area. So nowhere do they overlap. So if they do not overlap, that would be considered no solution. Okay? All right, so we have these two here. We have y is less than or equal to 2x plus 3. So let's graph that first. We know it's going to cross the y-axis at 3, and we know it has a slope of 2. Okay? So that's going to be a solid line, and it's going to be something like, I know it's not very straight on here, but something like this. Okay? And y is less than, so it's going to be all of this area down here, okay? Let's change this to blue, and let's say y is greater than or equal to negative 1 plus 2x. Well, we would want to do this to where it's 2x minus 1. So that's going to come down here and put a dot here. Same slope. You know what? Speaking of the slope, that is not correct. I did a negative slope. See? We all make mistakes. Let's see. This would be 3, 1, 2, 3, up to over 1. So this would be more like this, and it would be all of this area. And remember, I could check that because the origin 0, 0, if I plug that in there, 0 is less than or equal to 3, which is true, so it has to be that side, okay? Now let's go back to blue. So again, it's right here, 1, 2 over 1 here, and so it's going to be here. Well, these should be parallel lines, but you'll notice it goes this way this time. Well, all of this area overlaps. So all of that area would be the solution set. Okay? Number 6. Why don't you try number 6 and come back and see how you did. So let's see how you did. So the first thing I would do is convert 5x minus 2y minus or less than 6. I would change that to where it's in the y equals mx plus b, and that would be y is greater than 5 over 2 x minus 3. So I drew, it's a dotted line, drew the line where it goes, shaded the area above it red, then graphed the y is greater than negative x minus 1, and then the purple area up top is where they would overlap. Okay? All right. So apply a system of inequalities. When using a system of inequalities to describe constraints on the possible combinations in real-world problems, sometimes only whole number solutions will make sense. So in this case, it says Monica is running for student council. The election rules say that for the election to be valid, at least 80% of the 900 students must vote. She knows that she needs more than 330 votes to win. So we could say R is the number of votes required to the election rules, and V is the number of votes that she needs to win. So I know there's 900 students, so that's this line. And 80%, 80% of 900 students is 720, okay? So 720, she needs more than or equal to 720 votes. So that would be this area right here, okay? And we know there's a total of 900 students here, and so it would be this shaded area that she needs. And then on V, we have votes to win. She needs greater than 330. That would be this dotted line here, okay? And she knows that there is a total of 900 people. So again, anywhere in this whole area, but it would be the green area, is what she would need in order to win. Now, name one of them. I could pick any point inside here that would work. So 800 and 400. 800, 400 would be right here. And that is in the green area, so that is one combination that would work. Okay? So that tells me the combinations that she would need in order to win. All right. Let's see. So this says graph the solution set, lists 3 possible solutions to the number. So Mr. Flowers is on a restricted diet that allows him to have 1,600 to 2,000 calories per day, okay? So he's allowed to have 1,600, so that would be about here to 2,000 calories, which is about here. And it's all this area in here, okay? And then his daily fat intake is restricted between 45 and 55 grams. So 45 would be here, and 55 would be here, and it would be all this shaded area. So I know that it would be all of this area in this little square is what is allowed. So what daily calorie and fat intakes are acceptable? I have to list 3 points. Well, I could do 1645 because what's on the line is included. I could do 1850, and I could do something like doesn't matter as long as it's in there. So 1952. Okay, just 3 points. All that would be in that little square. All right. So you try this next one, come back, and let's see how you did. There you go. Check your answers and see if you're correct.